Now in this video, which is a continuation of my last video, or rather I should say I forgot to include something in the last video. What this is going to be about is showing how you can use your power line frequency, which is probably either going to be 60 Hertz or 50 Hertz depending upon where you are, to check the accuracy of your audio generator, your old audio generator at low frequencies. This is based on the assumption that your power line frequency is accurate. Nowadays, I think it's supposed to be 0.05% or something like that, short term. And I think what happens at the power production plant, I think if it drifts too far off, they reset that every so often, and then that brings it basically very close. Now, short term, of course, now I don't know. But I'm going to go ahead and assume here that it actually is 0.05%. You'd probably have to get a hold of your power company and ask them. So say, for example, if my line frequency is 60 Hertz and my audio generator is set to 60 Hertz and I get a circle here, that means basically both of the frequencies are going to be the same, and then I'm going to know, okay, my audio generator is not off by a hertz or more. It's probably going to be, I would say, a lot less. So what I have to do here then is I have to get an old transformer, which can be seen right there. It's an old transformer. It came out of some kind of radio. You can use a old filament transformer. And of course, all we do is put the oscilloscope across that. And we're just going to be, the line frequency can be measured then. Of course, we want to hook the scope across the secondary, thin wires, not across the thick wires, which is the primary, because that's the mains voltage. I want to be on the safe side. This is only, I think this is around, I'm not sure, this might be 10, 11 volts or something like that. And right now it's not plugged in, so my probe is going to be across there. Again, you want to be on the safe side and not connected across the primary. So I put the scope into XY mode, and I'm going to connect the channel 1 here, the X channel now, horizontal channel. I'm going to connect that to the secondary of the transformer I'm using, and my audio generator is going to the channel 2, which is the Y channel, the vertical channel. And what I like to do is I like to go ahead and, coming out of this transformer here, you're going to have a fixed voltage coming out, and I try to get the voltage coming out of my generator close to that, as close as possible. So of course I have to let everything warm up now, and I'm going to go ahead and start this experiment and basically see what I get here. I'm going to put this in the AC position here. This is in ground for some reason. Okay. And I've already got the generator set up to the line frequency, and of course the transformer is plugged in. Now here's how the figure looks if your power line frequency, which is our reference frequency, is when it's equal to the audio generator frequency. You're probably going to have a hard time getting this to stabilize the circle. It depends. It's really hard to move the audio generator controls in teeny tiny movements. So it's hard to get that stable, and then you've got drift and everything. So that's a problem too, whether it's power line frequency drift or your audio generator frequency drift. But this is pretty close here. So again, the power line frequency now equals my audio generator frequency. That's going to be my starting test. Now if I take it up to a multiple of if I take up my audio generator to a multiple of the power line frequency, let's say by multiple I mean we know the line frequency is say just for an example 60 hertz. Then once I adjust my audio generator to double that, which is going to be of course double that's a multiple of 60, that's going to give me 120 hertz, and then I can go to 60 times 3, that's 180 hertz, 60 times 4 is 240 hertz, and every time I reach those places, then we should be getting a reasonably slow Lissajous figure. Of course, it would be the same if your line frequency is 50 hertz and you're feeding in a 50 hertz signal from your audio generator. Once you double that frequency of your audio generator up to 100 hertz, then you should see a Lissajous figure here. It's going to look different, but it should be slowing down like this here. It shouldn't be that fast. So I'm going to go ahead and double the line frequency here. See what happens. You can see here, I'm not at a multiple yet. The multiple will be double my line frequency. Still there, not there? Because then we should see all this movement slow down, which is not happening. Okay, I think I'm going too slow. And we see it right there. We see it better right there. Now we can see it really good. So right now the audio generator frequency is doubled line frequency, and we see we got two tips, 2 to 1 here. There's one side, but two tips, so 2 to 1. So now I'm going to go ahead and take it up to 3 times the line frequency. Again, if it would be 60 hertz, 3 times the line frequency is 180 hertz. That's what you'd have to set up your audio generator to. Or if you live in an area where it's 50 hertz, you'd have to take your audio generator up to 150 hertz. So I'm going up now, and here you can see again, now there's 3 to 1 ratio. 1, 2, 3. Probably hard to get this thing to slow down. There it goes right now. You can see it really good. You can see it's moving, but it's going really slow. 1, 2, 3 tips to 1. So it's a 3 to 1 ratio. And you'd have to look at your audio generator. Say if your audio generator was on 3 times the line frequency, and you'd have to look at your control and see how close that was. If not, you'd have to go ahead and readjust or recalibrate your audio generator. Of course, with this method here, I can only take this up so far, because what you're going to reach a point where you get too many tips and you're not going to be able to read anything. So let's go ahead and go up to I'm going to try 10 times the line frequency. So again, if your line frequency is 60 hertz, then I would take the audio generator up now to 600 hertz, or if your line frequency is 50 hertz, then I would take the audio generator up to 500 hertz. So let me go ahead and try now 10 times the line frequency. See what's up with that. Then we should see it slow down soon. Now you can see it's still readable, but it's getting like hard to read here. And now we should get 10 tips to basically one side here, and I'd venture to say 1, 2, 3, 4, 5, 6, 7, 8, 9. It's really kind of hard to count. I'm more like guessing here. 2, 4, 6, 8. I would say it's guessing it's about 10. Again, that would be the limit. If you can even read this now, that would be the limit of this test for checking the low frequencies of your audio generator. So as a last test now, I have my audio generator at half of the line frequency, and you can see here I'm still getting 2 tips and of course just one side here, but the position now has changed here. Now my tips are on the side, not on the top anymore. So this is 1, 2, 2, and one side, basically 2 to 1. So my line frequency is double my audio generator frequency. Again, you'd have to take a look now, see what your audio generator, your control, your scale, see what it's reading. I mean, if it's off, let's say if you have your audio generator now on 28 hertz and you're getting this, then you know your audio generator is off. I mean, by a good bit then. Now there is one last thing I want to say. Earlier when the power line frequency matched the audio generator frequency, I was showing a round circle, which means both of the frequencies were the same. And if you look closely at that time, you notice it wasn't perfectly round. It had like two little jagged edges to it. And that's because it seems like the power line frequency, what you're looking at now, I've got the scope is hooked up directly across the secondary of the power transfer I'm using. You notice it's not a perfect sine wave. I guess nowadays it's hard to get a perfect sine wave from the power company nowadays. This is all I can guess. So that's basically what's causing that. I don't think I have anything else to add to this video.